The polynomials, the definition is they're made up of monomials. Monomials are little parts. So you put them all together and you make a polynomial. We'll talk more about them later. But for today, we're going to look at key features, things that are important, right? Degree. So when I talk about a degree, that's the highest exponent power. So what's the biggest power? Okay, so when the degree is 0, when there is no power, a polynomial looks like this. And it's called a constant. It's called a constant because it doesn't change. It's not increasing, it's not decreasing, it's just staying constant. Okay? If it has a degree of 1, an exponent of 1, then it's what we call linear. And it looks like this. Linear. It's a line. But this time it's increasing. It's not staying constant, it's increasing. Okay? The second one, 2, degree of 2 is going to look familiar from last year. Some of you guys told me on your get to know you slides. I remember that. This one, you talked about all second semester in Math 2. It's called a quadratic. It's called a quadratic. It's called a quadratic. We call it happy face. Okay? Arrows going up. That's where you stopped. In Math 2, in Math 1 and Math 2, you guys talk about the first 0 degree, 1 degree, 2 degrees, and you stop there. In this class, we pick it up. We pick it up and keep going. So 3 is a cubic. It's what's called a cubic. That guy looks like this. It's called a cubic, like a cube. Right? A cube has 3 dimensions. So that's why it's degree of 3. Okay? The next one is a degree of 4. That one's called a quartic. It looks like this. Quartic, so like a quart. 4 quarts make a gallon. That's why it's called quartic. Okay? And then the last one, actually, it keeps going, 6, 7, 8, 9, it goes to infinity. But I stopped at 5 just because you kind of get the idea. So the last one that we're going to look at is called a quintic. That one looks like this. And it's called quintic. And it goes on for, there's 6, 7, 8, there's an infinite number of degrees. But this kind of gives you a good picture. Look at the pictures, not the names, the pictures. What do you notice? Is there anything you notice? Patterns, things you're seeing, odd? Yeah. Some of them look like letters. Some of them look like letters, yeah. Which one? Like which one specifically? Which one looks like most like? Quartic? Yeah, quadratic looks like a U, right? Quartic looks like a W. And quintic kind of looks like an N? Good. What else do you see? What else?
It gets more bendy.
Yeah, they're the little humps, right? There's a little more humps. Every time there's a little more of these guys, right? A little bendy curves, whatever you want to, humps, whatever you want to call them, right? Definitely. Let me ask you this question. If you were to draw 6, could you get a picture in your head of what that looks like? So where would the arrows be for 6? Where would the arrows be going? Which way? Up, down? They both would be going up, yeah. Why up? It's a pattern, right? Which ones do you notice have arrows going up? Even numbers, right? Don't look at 0 because 0 is not a number. 0 means there's nothing there, right? 0 is actually technically not a number. So let's start with 1, 2, 3, 4, 5. What do you notice about all the evens? Their pictures are arrows up. What about the odds? Both, right? The left one is down, the right one is up. So 6 would be what? Up. 7, 8, so on and so forth. So if I asked you, which would 73, degree 73, it would be like this, right? It would be like this. And then it'd have a bunch of little humps in between, right? Because those go, the little humps increase, right? It has more humps as the number gets farther. So you'd be able to actually draw a picture, and it wouldn't look that bad, okay? So yeah, that's the kind of the idea. So those are positive, what we call positive. Now the negatives, what do the negatives look like? Well, they still have the same name. So they're still constant, linear, quadratic, cubic, quartic, quintic. But their pictures might look different. So let's see. A negative constant. Doesn't do anything different. Doesn't grow, doesn't go up, doesn't go down. It's just constant. Something that never changes. All right? Something that never changes. Linear. What does a negative linear look like? Well, that one looks a little different. What's the different about that one? Arrows are going the opposite direction, right? So the positive, is that going up or down? Up, right? We start the left arrow and go right. That's going up, right? This one, the red, is going from down, or from up to down, right? Okay. Quadratic, 2. Positive looks like a happy face, right? Negative looks like a sad face. All right. Cubic. Quartic. And quintic. 1, 2, 3. That's what they all look like. So what's different about them? What's different about their pair? They look flipped, right? They look flipped, reflected, right? What's the thing that changes? Does their shape change? No, they still have the same basic shape, right? A U is a U. A W is a W. You know, those kind of things, right? But what's changing? The arrows, yeah, the arrows. The arrows, if they were facing up, they're facing down. If they were facing down, they're facing up. That's all that changes. They still have the same kind of basic shape. Okay? All righty. Okay, so those are the pictures. Now, let's go to the terms. So the terms, I wrote them all down for you. I didn't want you to have to spend time writing them all down. Your job is to understand them. Understand what they are, okay? You don't have to memorize anything in this class. I don't expect you to memorize anything. I don't want you to memorize anything. That's why you get to use your notebooks, right? You use your notebooks because you don't memorize anything. But you have to understand it. So like on Friday for the quiz, if you ask me, Mr. Flores, what's a positive interval? I can't help you on quiz day, okay? I can help you today, I can help you tomorrow, I can help you Thursday. So your job is to understand them. So let's go over these. Let's start with some of these you recognize or they sound familiar, right? X-intercept, Y-intercept. Where does the graph, points where the graph touches or crosses the x-axis. Points, or the point where the graph touches the y-axis, okay? Relative and absolute, they're almost the same. The difference is one is in a specific neighborhood. One is overall, right? Maximum means high points. Minimum means low point. Okay? That's what those words mean, high point and low point. So like, for example, if I go like in my neighborhood, if I'm like, oh, that person has a nice house. It's the nicest house in my neighborhood. That is a relative maximum, right? They have a really nice house. But does that mean they have the nicest house in Fresno? Probably not. That's absolute. Okay, that's absolute. Okay? So relative maximum means something relative. Like if I go to Yosemite and hike up half dome. Okay, half dome's like, it's literally half, like on one side it's curved, on one side it's flat. That's a high point, right? That's a high point. Is that the highest point in the world? No, but it's a high point, so that would be a relative, right? The highest point, I think, is Everest. If I went on top of Mount Everest, that's absolute. That's the difference between them, okay? Positive interval, negative interval, where the function has positive y values. So I'm going to write a little note here. So that's above the x-axis. Above the x-axis. That's what it's asking. When is the graph above the x-axis? Negative is below the x-axis. Below x-axis. Above and below. Increasing means where is it going uphill? Increasing means uphill. Going uphill. Decreasing means going downhill. Okay? Increasing, I'm going uphill. Decreasing, I'm going downhill. Those are little helpful hints to when we're looking, because on the backside, we're going to be looking for all of these things. And so sometimes where the function has positive y values doesn't make sense. But if I say look above the x-axis, that makes more sense. Domain. So domain is all the x values. Range is all the y values. Okay? So that guy goes from left to right, and the range goes from bottom to top. Okay? So I kind of wrote them up here too. All x-intercepts start something, comma 0. All y-intercepts start 0, comma something. That's how they always start. Okay? All right, so on the back I have 3 different graphs. We're going to go through them. On the first one, I'll do with you guys. On the second one, we'll do together. And the last one, you're going to do by yourself. Okay? It's all the same questions. Where are these things on the graph? So let's look at graph A. Let's look at graph A right here. All the notes are right here. I wrote down all the notes right here. So if you didn't get a chance to write them, they're all right there. Okay. Okay, here's graph A. All right. So let's start with x-intercepts. Where does it touch or cross the x-axis? The x-axis is right here. Where does the graph touch or cross that? One spot, right? What number does it cross? 6, right? 6, comma 0. 6, comma 0. That point right there. So we're going to write that down. Next one is where does it cross the y-axis? This one starts 0 first. So where does it cross the y-axis? -5. -5. Good. Okay. So far, so good. Relative max. Relative means a high point, just a high point. So how many? How many do you see? How many just, it's a tall point. I see 2, right? I see 2 as well, right? These are the 2 that I see. Tall points, I see both of those as tall points, right? And they are. Are they the tallest? Maybe, maybe not, but they're tall points. We're just looking for tall points. So let's put that. So the first green dot, what address is that first green dot? -4, -1, right? So we're going to put -4, -1, comma, and then there was another tall one, right? 6, 0. Okay. How many low points does the graph have? Has one in between, but then aren't the beginning and the end kind of a low points? So we have 3 overall low points. Not overall, I shouldn't say overall. We have 3 low points that are considered low, right? In their neighborhood, like in this guy's neighborhood, that's the low point. Is it the lowest overall? Maybe, maybe not. That guy, it's the lowest in his neighborhood. That guy, it's the lowest in his neighborhood, right? So we're going to write down all 3. So the first one is -9, -9. The second one is 1, -6. And the last one is 9, -3. So there were 3 low points. There were 3 low areas. The difference with the next one is the absolute top. The absolute bottom. So absolute max means the absolute top, Mount Everest. Which point is Mount Everest? 60, right? 60. Which point is the absolute bottom? -9, -9, right? -9, -9. Okay. We call those extrema. Anything with a maximum or minimum is called an extreme. Isn't that extreme means you're way on one side or way on the other, right? That's what we call extrema, extreme, okay? Positive intervals. Okay, so positive. So if I go back to my notes, I see that positive interval meant above the x-axis. So you're going to trace. So watch me trace, and then you can do it on your own. So I start from the very left, right? The very left is that open dot. I'm going to start there, and I'm going to trace. And I'm going to see if I ever go above the x-axis. So far I'm below the x-axis. I'm getting closer. I go here, and then I go there. Did I ever go above the x-axis? No. I touched it, right? But I never went above. So there is no positive interval. So how do we write that? This is how you write it. If there is none, we put a circle with a line through it. We say none. That means none. Let's do that again, but look for below the x-axis, right? That's negative interval. Okay, so negative interval. So I'll use a highlighter this time. Okay, so we start here. I go down. I'm still negative, right? I'm still negative. I'm still negative. I'm still negative. Negative, negative, negative. I get to 0. So everywhere I'm below the x-axis, right? So where did I start and where did I end the highlighting? From this dot, right? From this dot here to this dot here. That's where I started and ended, right? From -9, -9 to +9, -3. When you write these, when you write them in interval, they only want the x's. They don't need the y's. So what x would this guy be? -9, right? Which x would this guy be? +9. So we're going to write from -9 to +9. How do we do that? Watch. It's an interval. So you're going to write an interval notation. You're going to write parentheses, start, end. The first one was -9, and then I finished at +9, right? It looks like a point, but it's not a point. It's an interval. It means it goes from -9x to +9x. When you're doing intervals, they only want the x's. The only one that doesn't want the x's is range. Range is a little different. So the rest of the intervals are all x. Okay, so now let's do increasing. Let's go back up. You're going to pencil test. You're going to do your pencil again. This time, when am I going uphill? When am I going downhill? So I'm going to highlight. Use a different color. Okay, so I start down here. Am I increasing or decreasing at the beginning? Increasing, right? Increasing, and then when am I changing? At this dot here, I change and I go downhill, right? So I'm going to change colors. I keep decreasing, and then when do I change going up? At this dot there, right? And then I go increase, and then when do I change decrease? At that dot there. Okay? So the green is where I increased. The pink, purple color, the magenta color, whatever it is decreasing, right? So we have to write the intervals. So let's start on the first one, increasing. Which x value did I start increasing? -9, right? Which x value did I stop increasing? So we're going to write that, parentheses, -9, comma, -4. So let's go write that down. -9, comma, -4. There was another spot that I was increasing as well, right? Which x value did I start increasing? Again, 1, right? And when did I stop? 6. So I'm going to put 1, comma 6. When there's multiple intervals, we put a little symbol. It looks like a U, but it means or. It means or. When there's multiple intervals, you always put that there. We didn't do that earlier. Why did I not do that for relative minimums or all relative maximums? Because it wasn't an interval. It was a point. Okay? Now let's go decreasing. So when did I start decreasing? Which x value? -4. And when did I stop? 1. There we go. So we got -4 to 1. Let's go write that down. And then there was another negative, right? There was not negative, decreasing. There was another decreasing. Where was that decreasing from? 6 to 9. Good. 6 to 9. And I'm going to put another U in there because it's more than one interval. Good. Okay, good to go. Domain. Okay, I'm going to show you a little trick. Domain is all the x's. I'm going to show you a little trick my teacher taught me back when I was in high school. Okay, so domain. Domain is all the x's, right? So I'm going to trace. And what I'm trying to figure out is, did I ever need to pick up my pencil to trace it? If I never pick up my pencil, it's continuous. So I start here, right? And I go, I trace, and then it goes down, reset, and then it increases again, and then it decreases again. So to go from edge to edge, from dot to dot, did I ever pick up my pencil? No. So it's continuous. Which x value is this? -9. Which x value is this? +9. So you're going to write an interval from -9 to +9. It was continuous. We say continuous. I never needed to pick up my pencil. That's left to right. Range is kind of the same, but top to bottom. Okay, so let's go look at range now. So if you had to put a bottom, a floor, what level would it be? What level would it be? Like at -7, is that a floor? It's not a floor if you go through it, right? This is the floor because we can't go through it, right? If you can go through it, it's not a floor. So if I were to put it at -7 here, that's not the floor because I can go through it. -8, am I still going through the floor? When do I not go through the floor? -9, right? So that's the floor. What's the roof? Again, it's not a roof if I can go through it. 0, right? So this one, I can't reach that high. Let's see. This one, now remember, range, we only use the y values. So why am I using the y values for this one? Because it's the range. So 0, right? 0, don't go through. So the bottom was -9, the top was 0. Okay, and that's it. So hopefully some of those made sense. If it didn't, we're going to do another one right now. Okay, I'm not going to turn you loose yet. We're going to do another one. If you're like, this makes sense, I know what I'm doing, show me. Do letter B. Okay? Remember, you can go ahead, just don't go slower. If I have more on my notes than you have on your notes, that's going slower. Okay? All right, so let's look at the next one. So do x and y intercepts. So right now, if you haven't already, do x and y intercepts. Where are the x and y intercepts? So it looks like I have an x-intercept here and an x-intercept there, right? So that's two of them. -7, 0, and 2, 0. And then it looks like I have one y-intercept right there. 0, -3. And 0, -3. Okay. Relative maximums, high points. Oh, sorry. I should have done this before. Before we continue, what's the difference? What differences do you recognize between graph A and graph B? I should have asked you guys this before. What differences do you see? There's no dots, right? There's no dots anywhere. Open or closed. Good. What does it have in its position? Instead of dots, what does this one have? Arrows, right? What do arrows mean on graphs? How long does it continue? Forever, yeah. So what we're going to call these, since we don't have dots on this one, we're going to call the arrows -infinity and +infinity. Sideways 8. Why am I calling one negative and one positive? Because the left, look all the x values. These are all negative, right? These are all negative numbers. And look at on the right. These are all positive numbers. So that's why I'm calling one negative and one positive. Okay? Anytime we have arrows, that's what we call them. We didn't do that for the first one because I didn't have arrows. Okay, so now where did we stop? We stopped at relative maximums. High points. High points. Where are the high points? Does this guy have high points? Kind of a trick question. Does it have high points? It does, right? But where are those high points? As far as it can go up, right? So infinity is not a number, it's an idea. What number is it? I have no idea. I just know it's way up there, right? So we do have high points, but those are arrows, and we don't know what number it is. So because of that, we say there are no high points that we can write down, right? Because the arrows are going up and up. Low points. Does this guy have low points? Yeah. How many low points does it have? One. It only has one low point. It only has one low point. I think right there, that little pink dot there. How do I know that's the only low point? Well, because I start by going low, right? I go down, and then I kind of peak, but then it keeps going, right? It's not a low point if I keep going down. Same thing, I keep going up, and then I keep going up, and then I keep going up. It's not a high point if I keep going up. So there's really only one low point. That's, what is that, -3, -6? Okay. What's the absolute top of this guy? Again, kind of a trick question again. What's the absolute top of this guy? Infinity, we don't know. We don't know, right? It doesn't have one because it keeps going forever and ever and ever. So that one's going to be the same as relative. What's the absolute bottom of this guy? That same one we had earlier, right? -3, -6, it's the same one. It was the low point in the neighborhood, and it was the low point overall. Okay, so positive and negative. Okay, so above means positive, so I'm above there, right? I'm also above here, the x-axis. Below means negative. Right? Okay, so yellow means above the x-axis. Green means below the x-axis. So let's start with above, the yellow, the first yellow. Where does it go? What's the interval from where to where? Where does it start being above? Negative infinity, right? And when does it go below? Negative 7. That's the interval. Okay? So from the arrow, from the left arrow to negative 7. So from negative infinity to negative 7. Okay? And then it goes down and hangs out there for a while. When does it go back up? 2 to positive infinity. 2, positive infinity. Let's write that down. Right, if there's another one, we write that symbol again. So 2 to positive infinity. How many times was it below the x-axis? How many green things did I have? Just one, right? When did it go below? Negative 7. When did it go above? Again, 2. So negative 7 to 2. There's only one. It didn't go below again. Uphill, downhill. When does my pencil go uphill? When does my pencil go downhill? Let's see. Okay, so if I were to start at negative infinity, let me use a different color this time. We'll use this guy. So if I were to start at negative infinity, am I going to start going downhill or am I going to start going uphill? Downhill, right? Going downhill until I get where? A negative 3, it looks like. Yeah, negative 3, it looks like there. And then I go uphill. Do I stop going uphill? No, I keep going uphill forever and ever and ever. So here's the tricky part. Students can see that, but where they struggle sometimes is, what do I call that? Well, where did I start going downhill? Negative infinity. When did I stop going downhill? Negative 3. So from negative infinity to negative 3. When did I start going uphill? Which x value? Negative 3. And then did I ever stop going uphill? Nope, to the arrow. Infinity. So negative 3 to infinity. Wait, I put them in the wrong spot. That should be downhill. That should be uphill. I switched them. Arrow to arrow, do I ever pick up my pencil when I trace? No. So what arrow was the left? What did we call the left arrow? Negative infinity. And what arrow did I call the right? There you go. I never picked up my pencil, so there we go. Range is the top and the bottom and top. Which one is this not going to have? Is it not going to have a bottom floor, or is it not going to have a top ceiling? It's not going to have a top. Yeah, why not a top? Because, yeah, it's always going to break through. So no top, that's going to be infinity. Where's the floor? I need to build a floor. Where is the area? Where is the line going to be where it doesn't go below? Negative 6, right? So negative 6, positive infinity. All right. Negative 6, positive infinity. No top means positive infinity. No bottom means negative infinity. All right, so what I want you to do now is do the last one on your own. Try it on your own. Do as many of blanks as you can. Picture this is Friday on the quiz. See what you can do. The nice thing about today, I don't grade it. You're grading your own. Friday, that one gets graded. So make your mistakes now. So 2 x-intercepts, 1 y-intercept. It was in between 0 and 1, so I just put 0.5. If you put 0.4, 0.3, 0.6, you're fine. 0.1, anything between 0 and 1. There are 2 relative high points. There was 1 relative low point. 1 absolute maximum, absolute top. There was no absolute bottom because of the arrows. The arrows are pointed down, so they're going down forever and ever and ever and ever and ever. Positive interval, where does it increase? Well, it starts increase, or sorry, where is it above the x-axis? So it starts at -8 and keeps going. It's never negative. Where is it negative? At the very beginning. From -infinity to -8, it crosses the x-axis. Increasing, where are we going uphill? Well, we start going uphill, right? -infinity to -6. And then I go downhill, and then I pick up again -1 to +4. Where do I go negative? -6 to -1, and then 4 to the end, infinity. Never have to pick up my pencil. So it's -infinity to +infinity. Where is the bottom? Where is the top? This one has no bottom. This one has no bottom because the arrows are there, so I put -infinity. The top, the ceiling, is at 5. The ceiling is at 5. Okay? Yeah, check.
Can you show us the relative minimum?
Sure, absolutely. Relative minimum, absolutely. Good question. Relative minimum. So the relative minimum is a low area, not the lowest, but just the low. So how do I decide where there's a low point? Well, I kind of do my pencil test. Wherever I change direction, that's either going to be a top or a bottom. So I'm going up, right? And then I change direction there, right? So that means that's going to be a top. And then I change direction again, right? Where did I change direction? There. And then I change direction one more time. So anywhere I change direction is going to be either a relative at least. So -1, 0. -1, 0. Now, what's the overall lowest? There is none, because those arrows are going to go down forever and ever and ever. Remember, relative means just in the neighborhood. Just in that neighborhood. So in this neighborhood here, what's the low point? Right there. -1, 0. Okay, great question. Anyone else have a question on, want me to show? Okay, so tape into page 7. Tape's in the back. So grab some tape, pass that around, let everyone get some tape.